Welcome, everybody. It's Dr. Adam here, and thank you for joining me today for Managing Varroa Effectively. This lecture is really intended to give you a full scope of understanding of Varroa as an organism, and then also the management that we utilize in the apiary to ensure that our colonies do not become victim to Varroa infestation and death of a colony by Varroa, which is very common here in northern Michigan and the Upper Peninsula during the winter. So let's get into it and discuss how we can actually work with this organism, manage this organism effectively so we're not losing bees every year to Varroa. All right, so the main thing when we talk about Varroa, the main thing that most beekeepers are concerned about in northern climates is winter survival. Beekeeping becomes very expensive if your bees do not survive year to year, and Varroa is the main driver of colony loss globally for beekeepers. So it's really important to understand the role that Varroa plays in your survivability in northern climates. Now, I hear things from beekeepers all the time trying to blame something else other than Varroa on the death of their honeybees. And one thing I hear a lot is it's too cold for my bees to survive in northern climates. And that is just absolutely not true. Honeybees are native to the northern reaches of Europe and are very well adapted to cold. And there's been plenty of research over the last 4 decades that has shown that bees can survive cold just fine. They're very well adapted for cold. It is not cold that kills your bees. It is something else, and primarily it is one of 2 things that you're struggling with likely in northern climates. And generally, what we see is Varroa mites being the main driver of colony loss, and typically, if your colony dies from Varroa, it typically dies before February in northern climates, and that's because of a few different reasons that we're going to cover here in detail just in a bit. The other thing that colonies tend to really die from in northern climates is starvation. And that's typically something that you see after the new year. Now, there is a third factor that contributes to overwintering loss that tends to be something that can be very deadly to bees, and that's moisture buildup and lack of moisture management. But these are the 2 main drivers that we see in folks that we work with, institutions that we work with, and in research that I've been part of, that we see these are the 2 main factors that we see as drivers of colony loss. Now, if it's starvation, it typically happens after the new year. And basically what that is that your colony has run out of food. It has blown through all the honey that you have on there. And that can be problematic for northern beekeepers because oftentimes our winters are very long. And so if you have a prolonged winter, it means you need more food stores, and starvation is a higher risk. The thing that really is disappointing is that beekeepers that make it past that kind of Varroa area of death, which is usually from November all the way through February, if you make it past that and your bees have survived, it likely means that Varroa was well under control. Your next factor doesn't mean you're out of the clear, but that next factor that can come into play is starvation. So another factor to think about. Now, Varroa has been in the United States since 1987, and it is rampant. It is everywhere in the U.S. Really, when you think about Varroa, it's not if you have Varroa, it's how bad the Varroa is. Every beekeeper is going to be impacted by Varroa. It doesn't matter who you are, where you're located. At some point in time, you are going to have to deal with Varroa. And what you can see from this graph, this is the honey-producing colonies in the United States over time is what you're seeing. So on the y-axis, we see that we have the total number of honeybee colonies in the millions. On the x-axis, you see the years that this data was collected in, and we're starting in 1945, post-World War II. Now, when we look and we see the population dynamics over this time, we can see that, U.S. honey population, beekeeping, honey-producing colony population really peaked right around 1950, and then we've seen this steady decline since then. But one of the biggest declines that you can see is this real big steep drop that we see here right when Varroa mite gets introduced into the United States. It was first detected in Wisconsin, was the first state it was located in, and so it's been in northern climates pretty much since it was introduced into the United States. The thing about Varroa mite is that it really is devastating to colonies, and you can see that right here in this graphic where right before Varroa was in the United States, we were hovering right around 4 million colonies. Since then, we have been steeply decreasing, and in modern times, when you look at 2007 is when this graph ends, but we're still at about 2.5 million colonies in the United States. We have really kind of bottomed out when it comes to population. And so even though we have more beekeepers now than ever, we have less colonies now than we've even seen before World War II. So that's problematic. And that is the biggest thing facing us as beekeepers, is the management of Varroa and the lack thereof of people in our industry, which tend to serve as reservoirs for the pest. If you're not managing Varroa, you're basically passing it on to everybody else. And that becomes a problem for the whole industry. And so when we're thinking about Varroa, it's not like it's this organism that just comes out of nowhere. It's in the landscape. So where are we actually picking Varroa up from? Where are bees getting it from? Because you're going to deal with it. You may, maybe you got lucky and got a group of bees, a package or a nuke that had no Varroa in it. Highly unlikely. But you got no Varroa in it. But Varroa is not just coming from your bees. It's everywhere in the landscape. So one source of Varroa is feral populations. Feral populations are populations of bees that tend to swarm from people's colonies. Those swarms that leave those colonies have been shown to have about a 20% survival rate once they leave a managed apiary. And the reason they have a 20% survival rate is because Varroa mite is not being managed, and it just devastates the colony. So feral colonies that are out in the woods, that are swarms that took residence in a tree or something like that and are not being managed effectively for Varroa, that is a reservoir then. Your bees are flying around, those bees are flying around, they interact with one another, and Varroa moves from one bee to the next. Your neighbors are also serving as a source of Varroa. If you have beekeepers around you that are not managing Varroa effectively, their Varroa becomes your Varroa. And we had this happen in our own apiary when we lived in Lansing and had an urban farm there. We had colonies that we had had for 4 or 5 years, well-managed Varroa all season long. And I had one colony one year that got bombed by another colony. And what I mean is that when Varroa gets so high in unmanaged colonies, they abscond. They just leave the colony. But they leave that colony with all the Varroa in tow. And then they join another colony, someone else's colony, they'll end up joining, and they bring all the Varroa with it. So in our situation, we had a well-managed Varroa hive that had well-managed Varroa, and in the late fall, we had a hive that joined it and totally devastated that hive. And the hive was dead by late November because of the high Varroa infestation. And we found the Varroa infestation when we did our autopsy, and there were just mites everywhere. So your neighbors can be a problem with this. This is one of the most challenging parts of beekeeping nowadays. Is the level of hobbyists that we have in the industry is very high. Everybody's well-intentioned. They all want to help bees. But if you're not managing Varroa, or if you just don't take the time to learn how to manage Varroa, this problem is on you. You're becoming part of the problem at that point. The landscape. There has been video that was done by, I believe it was the University of Florida a few years back, where they were tracking mites in the landscape and seeing kind of how they were actually moving. The notion previous to this was that mites basically move from bee to bee. But what we found with this video evidence was we found that mites actually will move on bees to a flower. So bee flies to a flower. The mite moves off the bee onto the flower and then sits and waits for another bee to come by. So the landscape is also serving as a reservoir for your mites and how they're getting to you. Nukes and packages. It's about 99.99% of hives in the United States have Varroa mite. It's like I said, it's not a matter of if you have them, it's how bad they are in your colony. So you're going to be getting mites coming with nukes and packages. It's just going to happen. No matter how well managed mites are, we never are eradicating mites. Mites are always present. We just manage them at an acceptable level. Migratory operations. So migratory beekeepers, big commercial beekeepers are moving all around the United States. As they move around, their bees are interacting with other bees, they're interacting with other landscapes, and they're invariably picking up Varroa mite. And so they're also moving those mites around as well. So mites are coming from all over the place. Now, the big thing that we need to understand as beekeepers is that when we try to prioritize what we're doing in beekeeping, your number one priority needs to be managing Varroa. If you don't, beekeeping is going to be very difficult and very expensive because your bees are just not going to survive. So why is Varroa priority number one? And why is it something that we dedicate the whole season to managing in order to ensure it survives? Well, number one, Varroa is a global pest, and like I said, about pretty much everybody has it. It's not a matter of if you have it, it's how much of it you have. And it's been in the US since 1987, so it's very well established in the US. This isn't a new pest at this point. We have a couple decades on this pest in the United States, so it's well established. Now, one of the biggest problems that honeybees have with Varroa is that Varroa is not a co-evolved species with European honeybees. It is co-evolved with another species of honeybees from Asia. And so because European honeybees and the Varroa mite are not co-evolved, it means that honeybees have never adapted any defenses against the Varroa mite. And one of the most clever defenses the Varroa mite has in protecting itself against honeybees and bees in general is that it has this quality called chemical camouflage. And what that means is that when a Varroa mite comes in contact with the particular hydrocarbons on the outside of a bee, those are the smells, essentially, that make up the outside of a bee, these molecules of odor. When a mite comes in contact with a bee, it takes on those odors. And so it essentially becomes invisible to smell. And that's how honeybees detect problems in their colonies, is through their antennae and the ability to smell these differences in chemicals, these volatile chemicals. Volatile chemicals are the language of bees. They're the language of plants and insects in general. It's the chemicals, and what they smell like is how they interpret their environment, how they interpret predators, how they interpret pretty much everything is through these chemical signals. And so because Varroa mite comes in and takes on the smell of other honeybees, it is essentially invisible in the hive to honeybees. And that's why it's so problematic, because the bees actually have no idea it's even there. And how do you deal with a problem if you have no way to even detect it? Now, as the mites are in these colonies and feeding on honeybees, what they're feeding on is they're feeding on a storage organ called the fat body. This fat body is much more than just a storage organ, and we're going to talk about the significance of the fat body here in just the next slide. But essentially, they're feeding on this fat body in both adult nurse bees and immature bees. So they're feeding on larval, pupal stages, and adult stages. Essentially all stages except the egg stage. So they're feeding on these bees while they're growing and while they're adults. And as they're feeding, not only do they compromise the fat body, but they also vector over 20 different viruses, many of which are fatal to honeybee development. One example is deformed wing virus. Deformed wing virus is already present in beehives, but when mites start feeding on bees, it has a pathway to get into the bees themselves. And what deformed wing virus looks like is, you see this little drone I took a picture of down here, and it looks like these wings are essentially like someone took a match to them and just singed them. They will never develop into full wings. This is a bee that cannot fly. And so a colony full of deformed wing virus is a colony that cannot fly. And so these are devastating viruses, many of them, to honeybee development. And so we have this kind of two-pronged attack by the Varroa mite. Not only is it feeding on a really important organ, but it's also vectoring viruses as well. So that's why it's so devastating. Now, going back to the fat body. The fat body is where this is feeding on these adult and immature bees. And what the fat body does is it has many different important roles. And this is just a sample of some of the roles that this particular organ plays. So one of the most important roles it plays is protein biosynthesis. So this is actually where really important proteins are being made, And one of the most important compounds that comes out of this is vitellogenin. Vitellogenin is a glycolipid protein, and so it's this really complex protein that's made up of sugar, fat, and protein itself. And what's so important about vitellogenin is that in other organisms, like say birds and things like that, it's a precursor for the egg yolk. So it really is the precursor, that protein precursor that allows for the development of an organism from a juvenile state. The other thing that vitellogenin is critical to in the individual bee themselves is that vitellogenin is the compound that equals longevity in your life. Queen bees have very high levels of vitellogenin, and the reason for that is because, well, vitellogenin allows them to have a prolonged life, so that's why your queens can last many years. Vitellogenin also needs to be in very high amounts in your winter bees. And so if your fat body has been compromised by Varroa mite and you have no ability to develop vitellogenin to basically create a winter bee, then you have no ability to have longevity. So your winter bees just don't have the ability to survive the 4 to 6 months they need to live. So vitellogenin is critically important to longevity and also the ability to raise new bees in the absence of pollen. And this is just a sample of what this fat body does. It is a very complex organ. And the other thing that it serves as is a storage center. So it stores lipids, it stores carbohydrates, amino acids, proteins. So it's also this storage center, and that goes into longevity, right? If you can store all of these things that you need to survive, then you have the ability to utilize them when they are not present in the landscape or available to you. And so this storage center is critical for long-term survival. If you can't store fats, lipids, amino acids, and proteins, you have no ability to survive the winter. And to highlight this, just to kind of nail this home, this is a picture that came out of a research paper many years ago. And what it shows is the bee on the left and the bee on the right are two different subjects. The one on the left has had a compromised fat body. The one on the right has a healthy fat body. And what you can see is that in this compromised fat body on the left, there are no fat stores. All of this white stuff you see on the right, those are fat body stores. You can see they're pretty much absent in the bee on the left. So if you have a compromised fat body, you literally don't have the ability to store the things you need to survive a long time in the absence of food. This is why your bees don't survive due to Varroa in the winter. Plain and simple. This is it right here. Your fat body's compromised. If you don't have a healthy fat body, you don't have fat, healthy winter bees, you will not survive the winter. So a healthy fat body is the key to winter bee production and survival, point blank. How do we protect the fat body? We manage Varroa mite. That's how we protect the fat body. Now, when we think about where the fat body is located and where you're going to see Varroa mites on adult bees, oftentimes people say, well, I never saw Varroa mite, so I didn't have them. It's going to be very difficult for you to see them. This is why we have monitoring methods, which I'm going to cover in this lecture. And those methods have been proven through research to be reliable detectors of mite populations and dynamics within the colony. So when you're looking at a honeybee and you see a Varroa mite on the back of its thorax, what that tells you is that essentially your mites are at such high populations that they're just kind of floating around theoretically throughout the hive. They're at very high populations, but generally you're not going to see them. And the reason is because of where the mites are located when they're feeding on the fat body. The fat body is located on the lower forward part of the abdomen. And so when you see Varroa mite on an adult bee, generally where they're located is this picture right here. One of the best pictures I took of last year. But what you can see is this is an adult bee, and right here at that lower abdominal segment is where our mite is. Now, Sam Ramsey did some research on this several years ago and actually showed that primarily where we find Varroa mite when we're finding them on adult bees is in this exact location. And you see on the diagram up here, about 60% of the time, and you look at that left view of the top diagram, about 60% of the time where we see that red dot, that's where Varroa mite's found. When you look at the opposite side of the body, same region though, that second area or that third area of abdominal segments right there, that's where you're going to see about 20% of them. So about 80% of Varroa mite, when they're on adult bees, are located on the lower parts of the abdomen. Difficult to see. So that's why we have developed these monitoring techniques, because you're not going to be able to tell if you have a bad Varroa problem because, they're all tucked underneath these abdominal segments. So that's something to keep in mind when we're thinking about how we actually monitor for mites. Okay, so let's talk about the Varroa life cycle. Now, there's two stages of Varroa, the phoretic stage and the reproductive stage. The phoretic stage is when they're on adult bees, and that's when they're moving around. And typically, life cycle-wise, we're looking at like 5 to 13 days in this stage, and this stage can actually last for months over winter. But during the season, it's a short process where they're moving from a bee into brood, or moving from a bee to a flower and then waiting for another bee. But in the wintertime, they last for months in the colony in this stage. Now, the reproductive stage, this is when mites are reproducing in capped brood. Bees in capped cells are where they're reproducing, and they utilize that capped cell as almost like a protective thing. So when you think about it, once they get into the cells, there's really not much any other bees can do about it, right? They're in a capped cell. This is a 10-day cycle for them as far as a life cycle to go from egg to adult. And they only breed in worker and drone cells. And when drone cells are present, they prefer drone cells because it's a little bit of a longer cycle. Remember, a drone life cycle is 24 days as opposed to 21 days of a worker. Now, what you can see in this diagram to the right is this is our drone life cycle right here from egg to adult, and then our worker on the right. And what you see is that when we get to day 9 here in the drones, or day 8 in the workers, which is the day that we start to get capped, that is when the mite actually goes into the cell from the adults. So from your nurse bees, drops into the cell. When we look at this, we have a 3-day cycle, and this is a mated female mite that goes into this cell. So she is able to lay eggs immediately. So 3 days in, she starts laying eggs, and the first egg that she lays is a male. A couple days later, she lays a female egg, and then subsequently lays another female egg, and so on. Now, once those female eggs are laid, now that male has turned into an adult and is ready to mate, and he mates with his sisters, those females after they turn into adults, and now you have females that leave the brood once it's uncapped by the bee that's hatching, leaves the brood and is mated and ready to create more mites. So it's a exponential process. One mite goes in and 2 to 3, 4 come out that are ready to lay more eggs. And so this process skyrockets very quickly over time. And so this 10-day cycle that we have in the capped brood, boy, that can get away from us real fast if we have lots of capped brood, bigger colonies. Big, healthy colonies are the ones that are subjected most to Varroa infestation because of these population dynamics. It is an exponential process. So if you're not managing Varroa and you're not doing it early on and things get away from you and you figure, oh, I'm just going to do a treatment in the fall, this exponential process is going to make it so that it doesn't matter what you do. Your bees are so compromised by high Varroa levels that there's no chance in hell that they're going to make it through the winter. Now, thinking about this, we need to understand also that it's not just this exponential process, but it's also the timing of Varroa population peak as opposed to honeybee peak. So let's look at this graph right here. What I want to draw your attention to, on the y-axis we see population size, and on the x-axis we see phase. And this is either mite population phases or honeybee population as far as a phase is concerned. What we see is in the winter, and early spring, they're essentially, bees and mites are dormant. They're not creating new brood. They're not laying. So bees are not laying, which means that mites can't reproduce. So they stay at these really low dormant levels. Season starts to increase as far as day length, temperature, snow's gone, all of those good things that we love about spring. And what happens with bees is that in the early part of the spring, bees start to ramp up very, very fast. And so usually by May and June, our colonies are just stuffed full of bees. And that's their peak population. Once we hit the summer equinox or the summer solstice, that's when things start to slow down for bees. So as day length continues to increase, so is that honeybee population with that day length. And now you get to this solstice and you've got a really big population of bees. Now, when it comes to parasite and host dynamics, in order for a parasite to take advantage of a host and be able to reproduce effectively, they have to delay their population increase to make sure that there's enough hosts to reproduce on. Simple parasitic host dynamics. And what you see here in this graph is that it's very true with mites. Mites wait for honeybee populations to peak in the summer, and after the population of honeybees peaks, that's when your population of mites peak. And at the same time, your honeybee population is rapidly decreasing because the colony is sizing down to get into winter. This is devastating, especially in northern climates, because we don't have a very long time to deal with any of this. This all happens within the matter of a few months. And this situation right here, if you have not managed mites throughout the season, and this peak hits while your bees are starting to collapse in size as far as the colony's population is concerned, you can't recover from this. I have seen fall mite counts on folks that did nothing over for managing mites all season long at 60, 70 mites per 300 bees. These types of numbers there's nothing you can do to recover from that. You could throw a mite treatment in there. It's not going to do much because the population is so high. All of your fat bodies on those bees have been compromised. You likely have Varroa viruses throughout the colony, and there's just no way you're going to recover from that. So that's why this is a season-long effort, is because the dynamics of population are not in our favor when it comes to mites and bees. Because as bees are decreasing in population, that's when we see peak mite population. And this tends to happen right around in the late part of the summer is when we see this. Mite populations tend to peak in northern climates, usually, northern Michigan and the UP, usually will peak right around the end of July, beginning of August, through late August is when we'll start to see peaks. It's all weather dependent as well. You always keep that in mind with honeybees. So in order to deal with all of this, we have to have some strategies and tactics in order to be able to combat Varroa mite. And the way that we do that is through something called integrated pest management. Now, integrated pest management is a sustainable, science-based decision-making process that combines biological, cultural, physical, chemical tools and tactics to identify, manage, and reduce risks from pests and pest management tools and strategies in a way to minimize overall economic, health, and environmental risks. So integrated pest management is a multifaceted approach to managing an organism in an agricultural system. It's based in science, and we use a tiered approach. And the reason that we use a tiered approach is because we're trying to minimize economic, health, and environmental risks to humans. When you're using things like miticides, these are EPA-regulated compounds. They can be harmful to humans, but they can also be harmful to your bees if they're not used properly. So let's talk about these different tiers of integrated pest management. So for Varroa integrated pest management, we have 4 tiers of what we call the integrated pest management triangle. And when we look at this triangle, we always start from the bottom and then we move our way up. as we deal with the management of an organism. Now, when you look at this, when we start at the bottom, that's cultural, and that is considered prevention. As we move up the triangle, we're becoming more interventive. So as we get closer to the top of that triangle, we end up using compounds that are much harder on the pests themselves, and also tend to be much harder on the environment, those types of things as well. Now, again, these are all EPA things that EPA approved things I'm going to be talking about. So these have been shown through research to not have those qualities. But we essentially don't want to just go for the hardest chemical first. And the reason for that is because if we were just to choose chemical compounds as measures to manage Varroa mite every single time, we would end up getting ourselves into a situation where we may run into the time when a product that we've used for years to control mites becomes ineffective because they've developed resistance to the compound because it's been used so much. This is also why when we talk about Varroa management, it's never just one product that we're using. It's never one tactic that we're using. We're using multiple tactics over the course of an entire season to ensure that the mites are always being faced with a different attack. Think of it from a defensive standpoint. If someone's coming at you with the same thing over and over again, eventually you're going to figure out a way to get around it. But if someone's coming at you with something different every single time, it's hard to adjust to that. And it's the same thing when we're talking about management of mites. It's not a one-step process. When people ask me, what do you use for controlling Varroa mites? I give them a laundry list, and I'm going to give you exactly what I do here just later in this lecture to show you the dynamic nature that we use in order to prevent the real huge infestations of Varroa mite and have good overwintering success year to year. So let's go back to the triangle. So the things I want to point out is when we start at the cultural level, let's look and see what are the things we can do to control at the cultural level. Well, what we're doing at this level is we're trying to reduce reproduction of the organism by something that we can do just as an early season choice that we may want to just put in place right in the beginning. No chemicals. There's no chemicals involved here. What you're talking about when we're talking about cultural controls, we're talking about things like resistant stock. And we'll talk about bees that are actually being bred in the United States and all over the world for what we call Varroa sensitive hygienic behaviors, VSH. And what we're looking at when we're looking at Varroa sensitive hygienic behaviors is we're looking at bees that actually can deal with Varroa mite on, well, it's a limited level right now. The other thing you can do for a cultural control is something we call a brood break, which is essentially where you have a break where there is no brood being laid. And I'm going to go into detail on each one of these. I just want to kind of cover them all over as one unit here in this diagram. That's just what we start with. That's something you can employ in every single operation right away to help with Varroa, no chemicals involved. But it's only one piece of that puzzle for management. The next one, we'll use mechanical controls. This literally means you're killing the mites by physical means. And there's a couple products that we can use for that. Now, one of them is mite trapping products. And we'll talk about drone brood frames that are created for you to be able to remove mites. Screened bottom boards. Now, this is on here because I want to bring this up. Screened bottom boards are not, they're part of the puzzle. They are not a one and done solution, okay? So just because you have a screened bottom board does not mean that you can avoid managing mites. It's just one of the pieces of the puzzle. And you can use that as another piece of the puzzle as a mechanical control. And what it is that if you use a glue board, a sticky trap essentially in that screen bottom board, when those mites fall, they get stuck on the sticky trap and they can't get up back into the hive. It's another way to remove mites mechanically. But again, it's not the only solution. It's a piece of the puzzle. So those are some mechanical controls you can use. After we get past the cultural and mechanical controls, that is when we enter into the time where we start using products like miticides. Now, there's two classifications of miticides. There's what we call hard chemicals and soft chemicals. The soft chemicals typically are derived from natural compounds, things that occur in the environment. When we're looking at this, thymol, so that's Apalife and Apiguard, produced from thyme, is one of the ingredients. Formic acid, produced from formic acid, which is a naturally occurring compound in honeybees. And that's Formic Pro and Mite Away Quick Strips. Oxalic acid is wood bleach. Naturally occurring acid, but it is also used as wood bleach. And it comes from the oxalic group of plants, oxalis. Hop beta acids, produced from hops, is Hopguard. So these are products that are derived from natural chemicals. We use these first before we use hard chemicals. And if you're absolutely back against the wall and you've tried all of these measures and nothing's worked, that's when you would jump into a hard synthetic compound like amitraz, which is Apivar. This is a step-by-step process that you should be taking every time you are working with honeybees to ensure that you're giving your bees the best chance of survival. So let's dive into each one of these control measures and talk a little bit about each one so you have a firm idea of what's going on in each one of these scenarios. Cultural controls. We're starting at the bottom of the pyramid again. These are hygienic behaviors. This is what we call them, as hygienic behaviors. And that is the Varroa-sensitive hygienic behaviors that I talked about just a bit ago. These are primarily grooming behaviors, and what they are is auto and allo grooming. So it means I groom myself and I groom my friends. And if you're constantly grooming each other, chances are you're going to start removing some mites. Now, the other thing that VSH bees have that other bees don't is they have this ability to detect, uncap, and remove pupa that are being attacked by Varroa in the cells. Remember, we said that Varroa reproduces in the cells that are capped. And so in order to remove Varroa, you've got to uncap a cell and take that larva, that pupal stage out. In order to even do that, though, you have to detect really small, nuanced differences in odor that regular honeybees, European honeybees, cannot detect. That's that chemical camouflage I talked about. Now, even though chemical camouflage provides a lot of coverage as far as the ability to mimic the smells of another organism, there are nuanced differences, very, very minor differences in the odor profiles of honeybees and mites, even when mites are on bees. Most bees cannot detect those, but bees that we breed for Varroa-sensitive hygienic behaviors can. And so they actively remove diseased cap brood that's being compromised by Varroa mite. Now, so compromised young immature stages. That's a pretty amazing ability. Russian honeybees also have this ability. And if you think about Russian bees, they're likely the closest Apis mellifera species to the species of bee in Asia that Varroa mites are native to. So they have this ability also. What this looks like as a behavior is first the bee is able to recognize that there's something wrong with the larva, with the pupa, the prepupa that is in there, in the cell. And you see this. We have larval stage here. This is prepupal stage. We're getting into pupal stage here. So they can recognize that there's something wrong with that cell. And by that recognition, they then uncap the cell. Once they uncap the cell, then they remove the mites through grooming behaviors. pretty amazing ability to get rid of the mites that we want to get rid of. So Varroa sensitive hygienic bees, that's that first thing. If you just decide you're going to go that route immediately with a VSH queen, that's a pretty good, you've given yourself a pretty good head start on managing Varroa. Now, there's many programs that have been dedicated to this for decades in the United States. I'm just going to mention a few here. One of them is the University of Minnesota's program that was looking at developing a Varroa-sensitive hygienic line of bees. And this started in 1993 through the Spivak lab. That's Marla Spivak right there in the picture. And essentially, they selected for these hygienic behaviors. And essentially, when you buy a Minnesota hygienic, usually what you're getting is the ability for those bees to control mites for about a year before a treatment's needed. Now, there's never would you ever install a VSH queen and just assume mites are under control. You always still monitor. But this is what we typically see from this line of bees, and these queens are widely available. So you can buy Minnesota hygienics from a lot of different places. Another program here in the United States is USDA's ARS program, the honeybee breeding and genetic program down in Louisiana. And this has produced a couple of different lines of bees that we use in the United States here that are Varroa sensitive hygienic. One of them is the pole line of bees. This is actually a line of queens that we use in our apiary. We have a couple of hybridized lines with New World Carnolians and Saskatraz bees that we developed, or we have been working with here in the UP for several years now. And I love pole line queens. They're really good queens, and they do good in northern climates. They have good management qualities and Varroa-sensitive hygienic qualities, and these are really available pretty widely as well. There's a lot of suppliers of pole line queens around. So that's another line of queens that you can look at for helping with Varroa right away. Another one is the Russian honeybee program. Russian honeybees have a disposition already in their genetics to understand and be able to detect Varroa. And so they were imported in the United States in 1997. And there's been an organized effort in the U.S. to have Russian honeybee breeders that are really focused on that line of bees. And so there's an actual association of these particular queen breeders. And right now, there's 17 lines available. They're still doing propagation and selection for qualities that they want, but these are also available all across the United States. Now, one thing I will say about Russians is make sure you're getting them from a reputable source. A lot of people have been saying that these are Russians. Maybe they bought some Russians a few years back and then created some nukes. Always keep in mind that genetic lines get diluted over time, and if queens are replaced, they absolutely get diluted very quickly. So, make sure if you're buying Russians, make sure you're buying them from someone that's a member of the breeder association or someone that has a very good reputation with those bees. So that is just to start off with. You just select good stock. In the plant breeding industry, or in the kind of ag side of things with plants, this is no different than selecting a disease-resistant plant, right? If you've got, say, for cabbage or something like that, say a brassica, a lot of brassicas are susceptible to powdery mildew. There's varieties of brassicas that are resistant to powdery mildew. So it's no different than that. It's selecting good breeding stock to start with. And that helps with the problems before they even occur. The other thing that you can do as a cultural control is brood breaks. In the spring, many of us make splits. And what I do when I'm making splits and preparing nukes is that as I'm preparing these, my old queens are going with those, because most of our customers want overwintered queens. Queens are proven to make it through the winter. So we sell our old queens, which gives us then a period of time where our colonies that we took those splits from are raising queens. That is called a brood break. A period in time where there's no brood in the colony, where essentially you are just taking a queen and they're taking a break. Now, when they're raising a queen, that's about it's 16 days for the queen to hatch, and then you've basically got a couple weeks after that before she's mated and laying. So it's about a 4-week process. So essentially, you have a 3 to 4 week break in brood. That means that those mites can't reproduce during that time. That's called a brood break. And so that helps with Varroa management as well, especially early in the season. You're giving your bees a break right before really big spring buildup, and you're giving them a break from mites before mites even really get a chance to start reproducing. You can also requeen. That is another cultural control that you can utilize to help with Varroa mite management. By requeening, I mean you could But if you have a non-Varroa sensitive hygienic line of bees, you can requeen with one of those as well. So again, another cultural control. Mechanical controls. The main mechanical control that we have for dealing with Varroa mite is drone comb removal. Now, there's also some devices that have been made over time. The mite zapper is one of them that was developed by a former colleague of mine at Michigan State University, Zach Wang, which is essentially a drone comb frame that has electrical circuits built into it, and you essentially heat the frame up with a battery and kill all of the brood in there, including all of the mites. Now, the reason that drone comb works is because mites prefer the larger drone comb cells. They've got a little longer time in them, 3 extra days in them, so it gives them a little longer time to reproduce, but they prefer these over workers. So when you're using drone comb removal as a technique for helping manage Varroa mites, you use this where you basically put this into your brood chamber, you let them draw wax on it, and once it's fully laid and capped, you take that whole frame out and throw it in the freezer and kill everything in it. And you scrape everything off of there and start over again. Really great way to remove a lot of mites at once, right? Because you got a whole frame full of them. Simple way to continue to contribute to the management of your mites. Really easy way to do it. One other way that I do this as well is that if we run somewhere between 50 and 100 colonies on our farm. This is another thing I just have to buy. One other thing that I utilize sometimes to help with drone comb production and removal is sometimes in a deep box I will put medium frames, and 9 times out of 10 the bottom of those medium frames they fill out with drone comb. And so when you come through and that's all capped, I just cut all that stuff off and feed it to my ducks. So again, you just want to get rid of that drone comb. So another technique here. At this point in time, we haven't even touched any chemical products at all. And you already have 3 techniques to help with managing Varroa mite. Now, this is just what we do to start. We haven't monitored for mites. We haven't done anything as far as calculating the number of mites per bees that we have in our hives. This stuff, mechanical and cultural controls, is just what we do off the bat to help with this process. Now, once we have employed these processes and we get into the season, we are going to have to start monitoring for Varroa mite to make sure that the number of mites never exceeds a specific threshold that has been developed through research. So let's look at mite monitoring, and I'm going to give you a step-by-step guide for Varroa management at this point. So we've talked about cultural controls and mechanical controls. You should just be implementing those no matter what. Now I'm going to show you the step-by-step process that we go through every single season for monitoring, and then if we need to, treating for Varroa mites. So when do we start monitoring for Varroa mites in northern Michigan and the Upper Peninsula? Well, we start doing that typically in late May through June, weather dependent. If we have a cold May, you're not going to do this. It may be until late June before you do this because the weather needs to be good and your bees need to be built out enough to actually do this. So you're not going to be doing mite monitoring on a 5-frame nuke. It's too small of a colony. You're going to be doing this on things that are pretty much, once you get to a full box of bees, that's usually when you can start monitoring, just as an easy metric. But while they're building out, while they're building out, you need to let them build out. But once they get to a good size, usually, and here it's usually by mid to late June, that's when you're going to start doing this. Again, temperature, seasonal dependent, which is why late May is in there. This is going to end as a process for you in September or early October. Weather dependent. If we have a really warm October and September, you may monitor into October. But the likelihood is that you're going to stop doing this in late September because usually in the Upper Peninsula in northern Michigan, by October, we start to see broodless conditions. You need brood in order to monitor for mites. So in October, oftentimes we're not monitoring for mites at all because we don't have the ability to. And you're going to monitor for mites on good days. 65 plus degrees and nights that are above freezing, those are the days that you're going to be selecting to do this. If you do this on cold days, you run the risk of chilling brood as you're trying to collect bees. And if you also do this on cold or damp or nasty days, the bees are going to be really upset at you. So do this on a nice day. This is going to be part of your monthly management and monitoring process. Inspections every single 3 to 4 weeks during the season, starting usually in about mid-June through late September. That's pretty much your schedule, every 3 to 4 weeks. And we do it every 3 to 4 weeks because bees' life cycles are 21 days for workers. So we're trying to get in there every 3 weeks to see what's going on. All right, so step 1 for monitoring mites. First, you have to decide which method you're going to use. And you need to learn it well. I will say that out of the 2 methods, the alcohol wash and the powdered sugar roll, the alcohol wash is the easiest and most accurate method, especially for beginners. The caveat to the alcohol wash is you are going to be killing 300 bees, approximately. Now, in comparison to a colony that's several tens of thousands in size, it's a very small subset of your population and will not impact the overall hive itself. But many of us have moral issues with killing bees. I put it this way. If this test provides you with an accurate way to ensure that that colony stays healthy all season long and all the way through the winter, you have saved tens of thousands of bees. If you have false readings because you're using a method that you're not real familiar with or is harder to use, you have the potential to lose tens of thousands of bees in the effort of saving 300. I mean, it's just something that we have to deal with. I used to not do alcohol wash. I used to always do powdered sugar roll because in powdered sugar roll, you don't kill the bees. But what I found over time is that oftentimes when I did my powdered sugar roll, I would follow up with an alcohol wash and I would find more mites without alcohol wash as a secondary monitoring method. So I'm just going to leave you with that. I'm going to talk about both methods here, but I just want you to understand that the alcohol wash is a foolproof method of getting mite counts. Powdered sugar roll is much harder, and I'll talk about that once we get to there. Okay, so for the alcohol wash, you're going to take a half a cup of bees, approximately 300 bees is a half a cup, and you're going to collect them from a brood frame. These need to be nurse bees. These need to be bees that are actively working in the nursery because that's where your phoretic mites are and that's where mite reproduction is taking place. You're going to take that half cup, you're going to place it into a jar. You see on my picture here, this is my jar with my alcohol and my bees in there. This is going to be 70% alcohol. You can also use windshield wiper fluid if alcohol is in short supply. You're going to take this cup of dead bees at this point, and you're going to agitate it for 2 minutes. And then in this situation, this one, you flip it over, and the alcohol washes out through the bottom, and the bees stay on the other side, and you're able to count your mites on the other side. So after my 2 minutes, I count my mites, and I determine how many mites I have per 300 bees. All right, the powdered sugar roll. Now, the powdered sugar roll is essentially done very similar to the alcohol wash. You still take a half a cup of bees, about 300 bees, and you're going to either take them off with a scoop or you can shake them off and off of the frame and pick them up out of a bucket. So essentially, you're just collecting a half cup of bees. You're going to place those into a jar, and then you're going to add powdered sugar to it. Now, what the powdered sugar does is it coats the bodies of the bees. You roll the bees in the powdered sugar until they're fully coated in the sugar. What it does is it causes the bees to heat up, and the mites come out from underneath those segments where they're hiding and feeding on the fat body, and then they can't get back on the bee once they get off of the bee because of the powdered sugar. You place it in the shade for a couple minutes, and that's the process of them heating up and the mites coming off, and then you shake it for 1 minute to separate the mites from the bees. And then you add a little water to that sugary mix that comes out, and you count the number of mites in that sample. Now, the problem with the powdered sugar roll is that it takes the right pressure of shaking in order to work correctly. And oftentimes people shake too hard or they don't shake hard enough. If you don't shake hard enough, the mites won't come out. If you shake too hard, the bees will put off venom and they'll actually cake up the sugar, which then makes it impossible for you to get those mites out. So oftentimes, when the powdered sugar roll is done properly, it's very accurate. But when it's done with too much or too little shaking, it's an inaccurate estimate, and it gives you a false sense of security because you have low mite counts, artificially low mite counts at that point. So if you're going to use this method, you do not kill any bees in the process, but it does take a lot of practice. And they've actually developed an app that has a sensor that shows you how to shake so that you get the right amount of shake, the right force, that you understand what that feels like, because this is a big problem with this particular method. The other big problem with both of these sampling methods is undersampling. That is, by and large, the biggest way that people get false senses of security for mites is that they actually don't get a half a cup of bees. They get, a little under a half cup. You need a full heaping half cup of bees in order to do this. So, once you get your count, what do you do with it? Once you get your count, this is what you do with it. So, you're going to calculate the percent of mite infectivity with the number of mites that you got from those 300 bees. Whatever number you get, you're going to divide by 300. So say, for example, you get 12 mites per 300 bees, and then you multiply it by 100. What that gives you is 4% mite infectivity. Now, through research, scientists like myself have developed what we call a threshold. And the threshold, what that means is that if you have more mites than the threshold, that you're actually starting to lose money. We call this an economic threshold. It's treatment threshold. If you don't treat at that level, your bees are going to start suffering. And directly, you're going to start suffering because your bees are going to start declining. In the spring, if you have 2% infectivity, say in June, that's 6 mites per 300 when you do a sample. That is your treatment threshold. You need to treat. This means that your mechanical and cultural controls, although they probably helped in some respects, they have not helped fully. And now you're at a point in time where if you don't do something, your bees are going to suffer. In the summer and fall, we give a little bit more allowance for infectivity because we're later in the season and we expect mites to have a high population in the end of the season. In the early part of the season, you should not be seeing 6 mites per 300 because mites are usually at a very low level. Remember our population dynamic diagram, graph that we had there that showed that mite population, it comes after the peak of bee population. So if you're seeing that number of mites in early spring, that's a problem. But when we talk about summer and fall management, it's 3% infectivity. So if you get 9 mites or more in your sample for monitoring, whether it's alcohol wash or powdered sugar roll, that means you have to treat. And again, the biggest issue with poor mite monitoring is undersampling, not getting a full half cup of bees. You need to get a full half cup of bees. All right. So now before we get into treatment options, this is step 2, right? So now we've done our monitoring. That was step 1. Say, for example, we have that 12 mites per 300, 4% infectivity. We've got to treat at this point. We're over the threshold. So now we're going to be talking about chemical products, those hard and soft chemicals at the top of the triangle. We're now up in the top of the triangle, those 2 areas, right? Where we're going to be adding some sort of a chemical control in order to help with our mite problem. Before we talk about any miticides, whether they're natural or synthetic, you need to understand a few key things about treating any bees with any product. All pesticides and miticides that you use in honeybees are pesticides. All pesticides used in agriculture are regulated by the Environmental Protection Agency. And they go through a very long registration process that really is seeking to understand how the chemical interacts with humans, animals, and the environment to ensure that they're safe to use. Once they go through that registration process, through the Environmental Protection Agency, a label is produced that is placed on the pesticide when it is sold to consumers. That label on any miticide product you purchase for use in honeybees is a legally binding document. If you misuse that pesticide and somebody gets sick as a result of it, that's on you, and now you are legally liable for the misuse of a product that's regulated by the Environmental Protection Agency. These labels need to be read in their entirety before you ever use a product. I don't care what Joe Schmo says on YouTube. The label is what you are bound to as a product user of a pesticide. You are not permitted under law to apply any non-registered pesticide to an animal used in agriculture. Your bees are an animal used in agriculture. This includes essential oils, something you formulate, something you find on YouTube and make in your bathtub. If it's not approved by the EPA and has an EPA approved label on it, you are not allowed to use it in honeybees. This is one of the biggest problems in the beekeeping industry. In other areas of agriculture, this is much less of a problem because in order to apply pesticides on a crop, you have to have a license from the state. If you're working in commercial agriculture, for a beekeeper, you do not, which creates a lot of problems because what you have is a bunch of people that are unfamiliar with the laws pertaining to use of pesticides in an agricultural animal operation. And they feel like they can just do whatever they want. And I see this on Facebook and YouTube all the time of crazy stuff people are putting in their hives and then selling the honey to somebody else. Just so you know, essential oils can be toxic in high amounts. Not all essential oils are just something that's innocuous. We think of certain things as safe. But if you're implementing something into a hive and it contaminates your honey and then you turn around and sell that honey to somebody, that's a problem. And that's one of the things that they look at through these EPA registration processes are how we keep people safe. So, EPA approved products. The only EPA approved products you are going to use in your beekeeping operation are these basically 7 products right here. You see 6 bullet points, but Formic Pro and Mite Away Quick Strips are 2 different products that use the same active ingredient. But you essentially have 7 products to choose from. That's it. That's not a lot of choices. And there are 2 more choices you may have. That's Checkmite and Apistan. Checkmite, the active ingredient, is coumaphos, and Apistan, the active ingredient, is fluvalinate. Both of these I don't have on this list because in research, they've both been shown to already have been developed resistance. Mites have developed resistance to these products already because they were used extensively when mites were first introduced, when we first started dealing with them. And because they were used so extensively, the mites have resistance to them. So, if you want to use Checkmite or Apistan, it's pretty much you're just throwing your money away. Because a portion of those mites are going to be fully resistant to those products. These other products that I have listed here, we have no research that supports any mite resistance against any of these products, which is why I have them listed. Now, the thing you're probably thinking of is, okay, well, there's my 7 products. How do I know what to use and when? And that's a hard choice for new beekeepers. What do I use and when? So I developed this cheat sheet for you to help with that process of deciding which compounds to use. And the reason that this is nice to have is because there's a couple things that you really need to keep in mind when you're using these products. One of them is, what is the temperature during my treatment period? Certain products are active at certain temperatures. Say, for example, you live in the northern part of the Upper Peninsula and you want to use Apiolife Var. Well, in order for it to actually even be effective, you got to have at least 65 degrees to 85 degrees for it to actually work. And it needs to be that temperature for 3 to 4 weeks. If you live in an area where you may not see that temperature for 3 to 4 weeks consistently during a certain part of the year, why would you waste your money on this product? It's not going to work. The other thing you need to keep in mind is the length of time that a treatment takes. If you live in northern climates, most of us don't have 6 weeks to sit on a treatment and let it work, because 6 weeks is like a third of our season. I'm talking about ApiGuard right here. This takes 4 to 6 weeks for it to be used, and it can't be used during the honey flow. I'm just thinking to myself, when do we have 4 to 6 weeks in the UP where it's 60 degrees or above and we're not in a honey flow if you're a beekeeper? That time really doesn't exist very much unless you're at the very end of the season. And at that point, are we really in 60-degree temperatures at that point in October? So based on where you're at, many of these products are going to be eliminated right off the bat. What I tend to tell people is, when you're looking at these products, look for a couple key things. Will it work for my environment? Do I have enough time to actually use this product because of the length of my season? And when am I going to be using it? And am I going to be using it during a honey flow, or am I going to be using it in the off season, say early spring or late fall when we're not producing honey? And that tends to be a key question, because if we ask ourselves, it's the middle of the season, June, July, August. This is when we're managing mites the most in northern climates. It's when our populations are peaking and building for mites in northern climates. If those are the 3 months that I'm focused on, I need a treatment that is fast and effective, because I don't have time to play around, and that whole time where I'm trying to monitor and manage mites is honey flow season. So I got to have something I can use when the honey supers are on. If you look at my important considerations over here, there are only 3 products that you can use during the honey flow. Those products are Mite Away Quick Strips, which is formic acid, Formic Pro, which is formic acid, and Hop Guard, which is the hops beta acids. Those are the only 3 products you can use during the honey flow. Oxalic acid is not one of them. I know that there is this huge misinformation campaign going, and I mean, it's not a concerted campaign, but it's a bunch of people that don't know what they're talking about, that are using oxalic acid 4, 5, 6, 7 times in a row, in succession, on bees, and saying that's an appropriate way to treat and use oxalic acid. That is absolutely in violation of the Environmental Protection Agency rules and regulations around the usage of OA as a product. Oxalic acid, by EPA regulation, is only to be used during broodless periods. And the reason for that is that oxalic acid does not penetrate brood cappings. And so all those mites that are being reproduced in the brood never get touched by OA. That's why it's only used in the early spring and the late fall when we're in broodless periods. It's a cleanup treatment. It is not a primary treatment. Get that into your head, because a lot of folks are using oxalic acid completely against the rules and regulations, and it is not to be used during the honey flow. I know there was an FDA document that came out a couple years ago that created a lot of confusion, that they're not seeing OA residues in some honeys. But it confused a lot of people to thinking that they could use OA during a honey flow. That is not the case. You cannot use OA during the honey flow. Oxalic acid is not approved for that. So if you look at that factor, I'm going to be managing mostly during the honey flow. You're down to 3 products. And most of these products are pretty much the same. They all have short periods where you're implementing them, and they all have good temperature ranges for the Upper Peninsula, Northern Michigan, and northern climates in general. Because generally, we're seeing 50 to 85-degree days during the honey season. So just by doing that, you can see that we've eliminated a ton of products. There's really only a select few products that we can actually use that are relevant to us. If we lived in California or down south in Florida, somewhere else, you can use products that take 4 to 6 weeks. It's not a problem because you have times where you're not in a honey flow for a month or a month and a half. We don't have that here because when we are not having a honey flow and it's a month and a half, it's winter time. So make sure you're making good judgments on what you should be using. Now, you're probably thinking to yourself, okay, so this is a whole lot to think about. How am I going to deal with all of this? And what am I going to use to decide how am I going to treat for my mites? I'm not even going to leave any guessing for you. I'm going to show you and tell you exactly what I do to manage mites. Our overwintering losses tend to be below 10%. So we have very good overwintering success. And this is why. Number 1, in early spring, if we feel like we need to, before brood comes on, we will do an OA treatment, an oxalic acid treatment. And for the early season treatment, I use the vapor treatment, which you see pictured here. After that, when brood starts coming on and temperatures start to shift and we're above 50 degrees during daytime and have some good nighttime lows, at least not totally freezing, no, we're not in the single digits, but we're in good temperatures, 30s, high 20s. That's when I start thinking about Hot Guard. Hot Guard's a really good early season treatment because it's pretty easy on the bees. All of these treatments are going to have a negative effect on your bees in one way, shape, or form. It's just the magnitude of negativity, and it tends to be pretty minimal for all of these products that we're talking about. But Hot Guard's real easy on the bees. And so when I have a smaller colony, say it's like 1 box of bees, I'll use Hot Guard in the early part of the season. After that, now we're into split season, and I'm going to give my colonies a brood break by doing splits. We sell all of our overwintered queens, and we raise new queens in these colonies, and we get a 3 to 4 week break from brood that allows our bees to recover from Varroa mite. Varroa mite's not recover, I shouldn't say that, but Varroa mite's is being knocked down very heavily because it can't reproduce. Late spring through early fall, I use Formic Pro. It is my go-to compound during the season. It is great during the honey flow. It's a short time period, has a good temperature range, and it is safe while we're using honey, while we're producing honey. In the fall, once we go broodless again, typically in October, that's when we hit it with oxalic acid again. And when I do this in that time of the year, I tend to use the dribble method for oxalic acid, another application method that is approved through the Environmental Protection Agency. This is exactly what I do in our apiary to have success. What you see here is a multifaceted approach. I should also mention, and I think I did in the early part of this, that on top of all of this management right here, this integrated pest management plan that I'm showing you on this slide, we have Varroa-sensitive hygienic queens. Pole lines is what we use. And so we've taken advantage of that cultural control as well. So within this little plan right here, you have all of the elements that we talked about in that integrated pest management triangle. We have our cultural controls with VSHBs, brood breaks. We're not using the drone comb frames, but I told you oftentimes we will install medium frames in deep hive bodies and then remove all the drone comb off the bottom of those once they're created. So another method there. Then we have our controls and these are only if we need to use them. If many times I'll go an entire season without treating a colony that has a brand new pole line in it. but we still have to monitor. Sometimes I may only treat once during a season. Sometimes I might have a colony that might need a couple treatments during a season. But we do it when we need to, not because we feel like we have to. Because prophylactic treatment of Varroa mites is helping nobody. You're hurting your bees because it is hard on your bees. Formic acid on the label tells you that you can expect to lose 1,500 bees a day for the first 3 days of application. That's an expected result. I get calls all the time with people that are panicking that they've got dead bees in front of their hive that they just treated with formic acid. But follow the label, follow the instructions to the T on these products, and they will be safe for you and your bees. All right, in summary, when do we monitor? We monitor every 3 to 4 weeks. We start usually in the Upper Peninsula in June, mid to late June, as early as May in the upper lower, temperature dependent. But once we start seeing good weather, that's when we start monitoring, every 3 to 4 weeks. We're going to end that typically at the end of the season, usually around the end of September, beginning of October, we'll stop with that monitoring. Reason being is, like I said earlier, your hives will go broodless in the winter, and they tend to go broodless right around late October. And so oftentimes if you're doing checks in October, you're not going to see a lot of brood anyways, and so you're not going to be able to get a good sample of bees to do your monitoring with. Next, where do we monitor? We monitor on the brood frames. We need mixed brood frames in order to get that capped and uncapped brood. We want nurse bees on those frames because those are the ones that got the phoretic mites on them. How do we monitor? We're going to either use a sugar roll test or we're going to use an alcohol wash. And like I said, I highly prefer the alcohol wash, and I definitely recommend it for beginners because the sugar roll test is problematic if not done correctly. And when do you treat? Well, in spring, you're going to treat at 2% infectivity level, and in the summer, fall, you're going to treat at a 3% infectivity level. And finally, if you don't manage your mites, point blank, your bees are not going to survive the winter. That's just the reality of the situation. So take this seriously. From our experience, when folks start taking mite management seriously is when their bees start surviving. I hope you enjoyed this, and we'll see you at the next lecture.